Hello CS240 students. This will be the first big idea that you need to know for understanding machine language and assembler. And the first big idea is memory. So we all understand that computers have memory which stores stuff. The memory is full of bytes, and we're going to represent the data that's in memory in binary, which we can make binary numbers. A single binary number could also be a character. It can be 8 bits long, it could be 16 bits long, and so on. So I'm showing here memory as a linear ordering of bytes that goes down the page. Each byte has an address starting at 0. And conventionally, those addresses 0, 1, 2, 3, and so on are spoken of and written down in hex. They're just numbers, but programmers like to use hexadecimal addresses. Imagine this kind of as a street, and along the street we have tiny little houses, each 1 byte. They're all right up next to each other, but we could go to a particular address and look inside and see the byte. And another thing we could do is we could go to an address and grab, for example, 2 bytes or 4 bytes in a row. We're showing here at address 31dog6, we're showing it contains a decimal 104, a hex 68, which is, as you know, an Ascii character, lowercase h. 31dog7 contains the next number, 105, which, as you may or may not know, is the Ascii character I. So 31dog6, 31dog7 contains 2 individual bytes. If we are to grab these 2 bytes, we'll get the word HI, or we could grab each byte individually. Starting at 31dog8, we have 4 bytes, and again we could get the 4 bytes individually, or we could grab 4 of them in a row. The 4 bytes contain the decimal number 1005, which in hex is going to be 3 easy dog. Here's 3, here's easy, here's dog. As a 4-byte number, it's actually 0, 0, 0, 0, 0, 3, easy, dog. And we'll note that the way this number is written in memory, the first byte that we encounter is at the right end of the number. Okay? And going through the 4 bytes, we go progressively. Easy dog is the rightmost byte of the number, 0, 3 is the next byte, and then so on. So this is what memory looks like. And one moment. And here we are looking at those same 6 bytes in the SASM assembler. And this is how a programmer would write in assembler coding the view of memory that the hand-sketched view of memory which we just saw. So this is inside the SASM, visual simple assembler. And we notice that we have written like this. And let's explain this. Foo is what's known as a label. A label is a name for an address. So that 31dog6, or whichever address it really is going to turn out to be, we're saying that the word foo is going to be like we wrote the address down on a piece of paper, and I can just use it. And here it says db is define byte. So we define a byte, and we actually made 2 bytes here, which were hi. And for strings, we have this special way of, we can just put the string in, and it does define byte, and it's 1 byte at a time. That's going to be a byte h followed by a byte I. And if we wanted, we could do the same thing down there, up here. db, why is it moving the cursor? I don't know. All right, we won't worry about that. But we could type db and then, all right, we won't worry about that. But we could do two individual bytes, h and I. My apologies. Bar is another label, and that's going to be just like in our picture. That's going to be 4 bytes down, or 2 bytes down. So here we're foo, 2 bytes, and then bar is 2 bytes after foo, because that was 2 bytes. And that's dd, it's a D word, is 4 bytes, and the number 1005 is in this 4 byte D word. So this is all in something called the data section. So in the data section of your program, we're looking now at a real live assembler program. In the data section of your program, you can put your variables and things that you want to save in memory. And this is essentially the assembler version of declaring your variables. But really, even though it is declaring your variables, fundamentally what it is just attaching labels to spots in memory and saying, I want about this much memory for my variable. I want about 2 bytes for this foo variable, and I want 4 bytes for this bar variable, and this is the values that they're initialized to. We can actually see here in the SASM debugger, it will have show memory. And I've put here, we can put here the name of our variable, and then we can see what's in it. So here we're going to say, starting from the label foo, I'm going to see bytes, and there's 2 bytes. And I want to see them in binary, and that's what we saw a moment ago in our PDF. This was, 1001, blah, 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 okay? So the first one and the second one, okay? And if I wanted to go to hex, I could go to hex, and here's hex 68 and hex 69, and in binary, or in decimal rather, it was 104 and 105. So these 2 bytes in memory, and bar was, we'll go to hex, okay, bar was our number, which was what? It was, here it was 4 bytes long, and here are the 4 bytes in binary, just like we saw a moment ago. I can turn those into hex, and that was 00, 00, 03, easy dog, where the first byte was the right-hand side of the number. And if I choose to look at this as a D word, and we want to go now to 1 D word, there's my 3 easy dog. It's 000003 easy dog. So that's the way that SASM allows us to actually look into memory, a byte at a time, a D word at a time. All right. If we want to see the ASCII characters, if I want to see the ASCII characters, there is H and I. And if I go to Smart, it'll show me I. And there's HI. So, by the way, if as I mentioned, these are going to be next to each other in memory. If I just go to foo, and I will go get, in hex, I will get 6 bytes, because remember that was 6 bytes, right? So here's my 6 bytes. Here's the H, I, and then the 4-byte number. They are all next to each other in memory, starting from the address foo, just like I advertised. So that is the programmer's view of memory. It contains, back to here, it contains a long list of bytes. We have labels that are attached to the addresses. Each byte has an address. We can put a label on an address. Starting from that label, we can go look inside the memory a byte at a time, or 2 bytes at a time, or 4 bytes at a time. And we can declare that as variables in our programs like this.